My name's Mark Murphy of Commonsware. You may know me from the Busy Coder's Guide to Android Development, 2,900 pulse-pounding pages on everything you ever wanted to know about Android programming. Though if you do find your pulse pounding when reading a programming guide, please consult your physician, as this may be a sign of a serious medical condition. And I'm here today to talk to you about power. Some people want to acquire power. Other people are trying to retain it. Some people worry if they have enough power and that are constantly seeking power. Sometimes they'll take power and that in ways that others may not appreciate. But enough about Game of Thrones. Let's talk about Android development. I was at lunch and at the table I was sitting at, I mentioned that I was delivering a presentation here talking about how Android app developers can work to use less power, and they said, "Oh, please," tell the developers how to use less power, because this is a perpetual problem. Android has a bit of a reputation for having low battery life, and sometimes that's hardware. Sometimes that's the operating system, and sometimes that's us. And we need to be able to figure out what we can do about that. And in particular, I am here to talk to you about Project Volta and what we're getting out of that. Now, if you've been doing Android development for the past few years, and I'm assuming that if you're in this room, you're doing Android development, because otherwise presentation slides with the little green guy in the corner and that may not necessarily be your cup of tea. But if you've been doing Android development for a while, you know that for the last 3 named releases, we've had these projects. Starting off with Jelly Bean's Project Butter, so named because Google marketing needed a name. And the engineering team apparently didn't actually have a name, and so they came up with Project Butter, after which I think marketing stopped asking them for names. And this was an initiative to go in and improve the smoothness of our UI. That's where we got that 60 frames per second update cycle for our views. Things like choreographer and triple buffered updates to the screen and so forth. KitKat gave us Project Svelte. Try to get Android to be able to run on less system RAM with an eye towards reducing the bill of materials for an Android device, particularly with an eye towards emerging markets, things like the Android One initiative that launched a few months ago, to be able to allow, if nothing else, to try to get manufacturers off of gingerbread and onto a newer version of Android, because a lot of the gingerbread devices are out there because it's simply cheaper to bring up a gingerbread phone. And so we got proc stats for helping us give a better idea how much memory our processors are using. Things like more flexible in-bitmap support, particularly for those of you who were in my memory presentation earlier today, and that will remember me mentioning that there. Lollipop gave us Project Volta, and that trying to have an eye towards consuming less power, so that we can stretch those battery lifetimes and make the users happier, and that rather than constantly staring at the little red battery icon in their status bars. And we've been given a handful of things that I'll be talking about here today related to that. Now, do bear in mind that these projects, to some extent, what we as developers get out of them is secondary. A lot of the work is under the covers, and it's the old iceberg. We see 10%, 90% below the surface. A lot of the work in these projects is to improve Android itself in terms of an operating system and the framework classes that we're using. And so they're applying these techniques to their own code as much as they're trying to give the things to us. And so, yes, we get the honor and privilege of having choreographer yell at us, and that when we're dropping frames, courtesy of Project Butter. But really, as much of anything, it was trying to make Android itself be able to behave better in that area. Now, power isn't a new problem. Like I said, we've got a history of having poor power performance. And we've been given lots of advice over the years from Google and others in terms of, how can we do a better job of network connectivity and that, so that we can do more work efficiently while the radio is powered on, yet at the same time try to prevent that radio from powering on quite so frequently. How do we do a better job of managing the mix of means by which we are getting our location data, so we don't necessarily have to keep the GPS radio powered on continuously? Things like changes in Alarm Manager to steer us in the direction of doing more inexact work, to allow Android to coalesce events, particularly for wake-up events where it can arrange to wake up the device out of sleep mode less frequently. Power Manager deprecations to steer us away from having wake locks that keep the screen on. Things like Wakeful Broadcast Receiver to allow us to be able to use wake locks without screwing up quite so likely. And stuff from Google Play Services, Fused Location Provider, GCM-based pushes and whatnot, and that all of which can help us in terms of our power consumption. And so we've been given lots of things along the way. And they've been used some, but perhaps not as much as Google would have liked. In part because, we're developers. We got a lot of stuff to do. And we worry about the pain that we're seeing. And so, for example, how many of you have gotten an out-of-memory error? That's pain. You noticed this. Your program crashed, and that's tough to miss. And therefore, okay, I got to do work related to memory management in order to try to avoid these out-of-memory errors. But battery is not nearly in your face. And particularly for ongoing development, we don't necessarily see the actual power drain, and to the extent that we do, it's not necessarily reflective of what users are going to be seeing in real-world uses of our apps. The primary way we'd figure out whether or not we had a battery problem is, do we show up on that list of consumers of power in the Settings app, what I call the battery blame screen? But that granularity is really coarse. We could be contributing to power drain in ways that are unfortunate, but we don't necessarily show up there. Or our work shows up there, but it happens to be associated with something else. The blame is assigned to some core OS component as opposed to be attributing to us. There weren't much in the way of tools for being able to figure out how our power consumption was being used. You just couldn't really figure it out unless either A, you had a device where you pop the battery cover off the back and you have a multimeter and very steady hands to try to measure the power drain, or you had to rely on specialized equipment. Stuff like the Qualcomm MDP series of devices, specially instrumented to be able to report battery drain by component. And their software, whose name I can't mention because I actually licensed it. And according to their license, you can't use their trademarks once you license it. And so I can't actually mention the name of their software. You'll have to find it out at developer.qualcomm.com. Hint, it begins with T. But their software for them working with the MDP and telling you, okay, here is where your app is draining power. And even to the extent that we'd figure out that maybe there were some power issues, spending the time to be able to use all this cool stuff to be able to take it into account, well, that's engineering time. And engineering time also has to be spent on other things that may be more what our bosses and that are interested in. And, fiddling around with a lot of tricky little low-level stuff to try to minimize your power drain, and that is not something that, a lot of developers have expertise in. And therefore, it takes time. We may not have the time, depending on the nature of the project, the nature of the development team, and so forth. And so what we really needed out of Project Volta was better tools for us figuring out what are we consuming. Are we draining power? And where? Why? How? And more stuff that we can take advantage of in order to be able to do a better job with power, so that we don't have to necessarily wake up the devices frequently, or that we can do other things that in the natural course of using Android, we happen to use less power by switching to this API versus that API. And so those are the sorts of things that we really needed out of Project Volta. So what did we get? We got JobScheduler, which admittedly some people will refer to as JobScheduler, and I talked about this stuff in London recently, and I had to change my presentation around a bit. JobScheduler is basically what Alarm Manager really should have been from the beginning, and that much more intelligent component than what the classic Alarm Manager is. We'll go in depth on JobScheduler. We got battery stats, a way that we can get a ton of data about what's going on in terms of power on the device but it's a bit of a fire hose, as you'll see, and therefore a little bit tough to decipher. We also have battery historian, which takes the battery stats output as input and turns around and gives you an HTML timeline visualization that takes it from a fire hose down to probably about 24 garden hoses and that point it all at you. And that the less likely to drown you, but still kind of uncomfortable. But we'll get into that as well. The biggest win today in terms of Project Volta is JobScheduler. JobScheduler's primary objective is to be more intelligent about when it gives us control compared to Alarm Manager. How many of you have used Alarm Manager? Okay. And so, for those of you who haven't, Alarm Manager is kind of Android's equivalent of cron jobs, or your Windows scheduled tasks are the equivalent. You tell Android, here's when I want to get control, and maybe for a repeating job, here is the period, how frequently I want to get control, and here's what I want to have done at those points in time in the form of a pending intent, so I can start an activity, start a service, or send a broadcast. The problem with Alarm Manager is it only knows about time. And that means that it's oblivious to anything else that may be important criteria for whether or not we can get our work done. If we're trying to get control every 15 minutes to download new email messages from the POP3 server for our email client, it doesn't do us a lick of good to get control if we don't have an internet connection. Alarm Manager doesn't know anything about that. Alarm Manager says, 15 minutes, here you go. And then we look around and we say we don't have an internet connection, shrug, and we have to skip the event. JobScheduler, we can teach it more rules. Only give me control when certain criteria are met, in addition to timing rules, and therefore Android can be a little bit wiser about when it actually gives us control, and therefore try to minimize the amount of work we're unnecessarily doing. JobScheduler persists across reboots, if you want to. And so therefore the jobs you set up, you can arrange to, if the user reboots their device, because maybe the power ran out, and that your work can then pick up again from where you left off, as opposed to Alarm Manager where you're on your own for that. You have to register your own boot time broadcast receiver and be able to rebuild your alarms and that from scratch. And the API is pretty clean. In many ways, it's a bit easier in order to be able to implement something sophisticated with JobScheduler than to do the equivalent work in Alarm Manager. Though there is a bit more code involved, and that just due to the nature of the API. To use JobScheduler on Android 5.0 and higher, you're going to need to implement a jobs service. Just like intent service, accessibility service, input method, abstract input method service, and so on. This is a specialized service designed specifically for using with JobScheduler. When you put it in the manifest, you're going to defend that component with bind job service, saying that the only things that can talk to this service have to hold that permission, and that's a signature level permission. Only the operating system is going to wind up being able to hold that permission. Just as in an intent service, you'll override on-handle intent to do your business work, you'll have on-start job and on-stop job in the job service. I don't mean to shock you, particularly right after lunch here, but on-start job, your job is to start the job. And an on-stop job, you need to stop the job that you had started in on-start job. The key is that both of these are going to be called on the main application thread. The same main application thread that's driving your UI. The same main application thread the choreographer yells at you about. And so therefore you don't want to be doing the work on that thread, and that instead you're going to be wanting to fork your own thread, do the work asynchronously. Or possibly take advantage of some API that's in Android that's intrinsically asynchronous, if that happens to be an option for you. When that work is completed, you can call job finished to tell JobScheduler, hey, the work related to this job is done. We don't have to worry about this anymore. On stop job will be called if some of the criteria you had specified for when your work should be done lapses. For example, you said that I only want to do this work if the device is idle, that the user is not using it. Then all of a sudden the user picks up their phone and starts working with it while your job is still going on. Yeah, the Android's going to let you know, an on-stop job, hey, your criteria no longer hold, please cease operations. And your responsibility then is to cleanly tidy things up, and ideally as quickly as possible, so that, for example, in the case of idleness, that you don't wind up consuming CPU time and bandwidth and so forth in the background that might interrupt the user's game or video or whatever it is that they're starting to do. One quick logistical note, by the way, and that these slides, I will be tweeting out a link to these slides. I'm not sure whether the conference is publishing them or not, and that if you follow me on Twitter, I'm Commons Guy there, and that I will send a tweet out either later today or tomorrow, and that with a link where you'll be able to download this presentation. And with that, if we could switch over to the demo notebook. You're looking live at Android Studio, and I'm going to pull up a job service. And why not also pull up a manifest? And so I have a service element for my job service named demo job service, where, as I mentioned, I am defending it with a bind job permission attribute. Only things that hold that permission are going to be able to send commands to me, which basically means it's only the OS itself. Demo job service is a job service, which is an android.app.job.job service. We have a new package, android.app.job. In onStartJob, I'm passed a job parameters object. This serves two roles. It is a representation of the job itself. You can think of it as kind of a handle to the job, plus it contains information about the job that's supposed to be done. In particular, it has extras, much like an intent has extras. The biggest difference is that those extras are in the form of a persistable bundle. You've no doubt used bundle somewhere along the line, and that if nothing else, it's that funny little parameter we get passed to onCreate in our activities. Bundle is not a hash map, but it looks like a hash map, key value store. Persistable bundle is a bundle that can be persisted. Bet you wouldn't have guessed that. This is why you come to conferences like this. Really what they've done is they refactored bundle. They moved a bunch of core logic up into a base bundle class, of which bundle inherits and persistable bundle inherits from. And so persistable bundle is where we're going to be able to put information about our job that Android will automatically persist for us. Again, being able to pick up our jobs where we left off after a reboot. Part of that is being able to describe those jobs in the form of values we put in a persistable bundle. However, for reasons that remain inexplicable to me, while a persistable bundle can hold on to ints, floats, and strings, it can't hold on to booleans, which you would think would be the easiest thing to persist. But they didn't include it. I don't know why. I have an outstanding issue on b.android.com, and heck, maybe it'll even get addressed someday. And so therefore, I wanted to pass a flag into this, and now I got to do it as an int. And so I wanted to indicate in this particular sample application, I am going in and giving the tester some options for being able to go in, and I forgive the kind of fuzziness of this display, and that the application is designed to experiment with different options for doing recurring work. We can go in and say I want to do an exact repeating alarm, an inexact alarm, or use JobScheduler. How frequently I want the work to be done. Whether or not I want to download a file as the work, or do I just want to like wake up and log something to Logcat. And then that scheduled switch will go in and actually arrange to start doing the work specified by the other widgets. If we switch it back off, and then it stops and cancels all that outstanding work. And so I needed to let the job service know, hey, are we supposed to be downloading a file? And so therefore I have an int that I put in the persistable bundle. Keyed as key download as an int, as opposed to if it were a Boolean. And so if that is 1, that means, yes, I want to do a download, 0 otherwise. If I do want to do a download, I need to fork a thread. I've got a download thread that's going to be able to go in and get information from those parameters, turns around and runs a download job where I have centralized logic where my exact and inexact alarms will also use download job to actually do the real download work, standard HTTP URL connection stuff. And so I just fork that thread, hold on to it, and I return true, indicating, yes, I was able to arrange to do the work. If you return false, this means for some reason I couldn't do the work right now. For example, maybe I have an internet connection, but the server's down, and that the user is hooked up to a Wi-Fi access point where somebody unplugged the WAN cable, or whatever. And so therefore, even though I've got a connection, I can't really do what I'm supposed to do. False is going to indicate that I would like to have this work be rescheduled at a later point. We'll get more into that in a bit. On stop job then will be called if, while the job is still executing, Android says, cut that out, and that some of your criteria that you had specified for when this work should be done is no longer in effect. Please cancel that outstanding work. And so I turn in and I interrupt the job, where the download thread, when it's done, calls clear job, which goes in and nulls that out. And I lost my job finished call. Oh no, there it is. And then I also call job finished to say the work has been completed. I identify the specific piece of work via that same job parameters object. Again, it's a handle representing the job. False indicating we don't need to reschedule this. It all worked just fine. If we could switch back to the slides, please. Then you need to arrange to actually have this work occur. To do that, you'll create a job info object via a job info builder, much like we use builder objects for things like notifications. You'll call build on that builder to get the job info and pass that to schedule, a method available on a job scheduler, where job scheduler is another one of those system services, and that like Alarm Manager itself. What's interesting are the various methods that we have on the job info builder object. Set required network capabilities says only give me control if we have a network connection. Or none, meaning we don't have a network connection. Or unmetered, meaning yes, we need a network connection, but one that is not metered, which usually will mean Wi-Fi. And therefore, if the current network conditions do not match, at the point in time when we should be getting control, Android will not give us control and will instead arrange to reschedule that work. Set requires charging. Only give us control if the device is plugged in to some sort of power source. Set requires device idle. Only give me control if the user is not using the device at the moment. Now, unfortunately, idle here is not well documented. And that it's probably safe to assume that the screen has turned off at this point in time, but whether or not there is an additional period of time of quiescence before it goes into idle mode, that's unclear. But if we can safely assume that if the device is idle, the user hasn't been working with it, and therefore the fact that we happen to be consuming CPU, bandwidth, and so on, and that won't impact anything that they might be doing in the foreground because they simply aren't there. As with Alarm Manager, you have your choice in JobScheduler of whether or not these are repeating events or one-off events. If it's a one-off event, we want to get this work done once and we're done, or it'll reschedule itself for some sort of maybe an irregular schedule. You'll have options on the builder of set minimum latency and set override deadline. Set minimum latency says don't even think about doing this job until at least this amount of time has elapsed. And it won't do it any earlier than that. But then from that point on, it's going to start looking for, okay, have we met the other criteria? Is the device idle? Are we charging? And so forth. And it'll execute the job at that point in time, where you can also, in set override deadline, say, I don't care. I need to get control, after this number of milliseconds, regardless of those other criteria. But that does mean that those criteria won't be met. Some, like whether or not we're charging or whether or not we have a network connection, we could figure out on our own. Idleness, you'll pretty much just wind up, saying, okay, well, if I'm using the override deadline, then I want to do this work regardless of whether or not it might cause a bit of jank in whatever the user happens to be doing in the foreground. And so set override deadline, use that sparingly. If you want to have the work be done on a regular schedule, set periodic indicates the interval. It will only run once during that interval, and like inexact alarms, Android will choose where in that interval it'll do the work. And so this is an inexact sort of an event to allow Android to coalesce this with other jobs, other scheduled alarms that are inexact so that we can, in particular, wake up the device out of sleep mode less frequently. The default is going to be that it's going to continue doing that work until either, well, by default, true default, it'll be until the phone is rebooted. If we want to stop the periodic work proactively, such as in my GUI when I switch that bottom switch back off, cancel or cancel all will achieve that. Cancel says cancel this individual job. Cancel all says cancel all jobs that I have scheduled with the job scheduler. If you want to have it survive a reboot, there's no code involved, but you still have to have the receive boot completed permission. Because Android itself will do a little work on your behalf on a reboot, and therefore they want the user to know that Android's going to do a little work on your behalf at reboot time. And so you don't have to have the receiver, but you do have to have the permission. And so the user will see at install time that you intend to get control at boot time. Historically, that doesn't seem to be a huge problem for most users. If at the time it comes to do a job, the environmental conditions don't match, either the ones you proactively set, such as the device was not idle, or ones that you determined on your own, causing you to indicate from your on-start job and that, hey, I couldn't do the job, Android will then implement a back-off policy for retrying that work. The default is a 5-second exponential back-off policy, and so it'll try again 5 seconds from now. If it's still not ready, 25 seconds. If it's still not ready, 125 seconds, up to a maximum of 5 hours. If you want, set back-off policy on the builder will allow you to configure that. And that, what is the amount of time, and do you want a linear versus an exponential back-off in terms of the way that then increases. And so a linear 5-second delay would be 5, 10, 15, 20, and so forth. And so you'll be able to go in and determine how frequently Android is going to retry the work. Now, it may be, for particularly the ones that you're canceling or abandoning more manually, because, for example, say the server didn't work, you might say, well, yeah, okay, the work didn't happen here, but that's okay. I'll just wait till the next polling cycle and don't actually have it go through the back-off work. The back-off is there for if you specifically want to be able to try to do this work before the next period of a periodic job, or if it's a one-off job, you want to still have a shot at trying to get that work done. If we could switch back to the demo machine. So let's look at where I'm actually scheduling this stuff. I have an activity that is got a user interface that I showed you. And in particular, if they toggle the switch, I'm going to go in and I'm going to call a manage job scheduler method if job scheduler is what we said we wanted to have done. And that's going to be passed to Boolean to determine whether or not we are now starting the jobs or whether or not the user has toggled that bottom switch off and therefore we're canceling the jobs. So I create a job info builder object. You provide it 2 parameters in the constructor. A unique ID identifying this job. It has to be unique for your application. It does not have to be unique for the whole device. And you provide the component name of the job service. And so you'll make it an appropriate component name constructor. You can then create the persistable bundle. That will be your extras and put stuff in it, such as if the download switch is checked, I'm going to stuff that 1 into the persistable bundle, key download as an int. Then I can call set extras on the builder to say, here's the extras that I want you to hold on to for this job, not only to tell the job service now, but also to hold on to in case of a reboot. Though I don't, as it turns out here, say that I want it to persist across reboots and that I'm perfectly content allowing these jobs to be canceled when the user powers off their emulator or device. However, I do indicate, if I'm supposed to be downloading something, I need some sort of a network connection. And so I say I need network type any, versus I'll say network type none if I don't need a network connection because I'm not trying to download anything. That's the default, and that I have it here for illustration purposes. I then indicate that it's to be a periodic job. I want it to occur every so often, where I've got a method that looks up for that one spinner and returns the appropriate number of seconds. Note that it's seconds here, not milliseconds. Set persisted false, saying I don't want this to survive a reboot. We're happy to allow this work to get wiped out on a reboot. I don't necessarily need the device to be charging, but I do want the device to be idle. And then I just have my builder build my job info object. I had retrieved a job scheduler up here in onCreate via get system service. Note that you may need to add a particular annotation. It may be fixed now in 0814. I haven't upgraded to that yet because I never tried upgrading my IDE in the days before a conference presentation because my last name is Murphy, and suffice it to say, I usually have stress then. I'll upgrade tomorrow. And that may be fixed already in 0814, I think it is. But in earlier versions of Android Studio, it didn't recognize the constant of this job scheduler service. It said that's an invalid value to provide a get system service. And so you had to put the suppress warnings annotation in there to get Lint to stop yelling at you about what is perfectly legal code because they missed a couple of new system services in Android Studio. Again, that should be fixed now. And so I go in there and I schedule the jobs, and as soon as the user clicks the switch to back off to say I don't want those jobs running anymore, I will cancel it, passing in the ID. I could call cancel all here because I only have the one job and they'd be equivalent, and that either way would work. And so you set the stuff up, and it's going to give you control in and around those points in time. Your job service is going to get a chance to do its work. And so it is reminiscent of using Alarm Manager, but you've got more criteria for controlling when you get control. And that there's a built-in back-off mechanism in that rather than you rolling your own. It's got the persist across reboots facility and so it is Alarm Manager with a lot more capabilities and intelligence. If we can switch back to the slides, please. If we could switch back to the slides, please. Thank you. The biggest problem, of course, at the moment is that Job Scheduler works on Android 5.0. Which is running on approximately 0.0% of Android devices today. Which makes it somewhat uninteresting, at least at the moment. Of course, that's going to grow, eventually. But, ideally, we'd have a backport. Ideally, Google would have shipped some sort of Job Scheduler compat inside of the Android support package, but they didn't. I have no idea whether Google is actually working on one of these. They could be, because it should be possible to create one of these. Not every feature would necessarily work. Idle awareness in particular, and that is likely to be something that can't readily be emulated by a library that a third-party developer might create. But you could easily create an API-compatible implementation where, like with notification compat, you ask for certain features that are only available on newer Android devices. Notification compat will either substitute its own backport of the individual capability or simply no-op your request. Job Scheduler compat and the equivalents for job info would do the same basic sort of thing, that they give you a code-compatible API using the real implementation on Android 5.0 and higher, and faking it as best they can on older devices, particularly using Alarm Manager. I've been told that there are people working on these, and so I'd pay attention to the Android arsenal and related resources to see when this sort of thing shows up. And if nobody else does it, I suspect somewhere in 2015 I'll have the itch to scratch and we'll wind up creating it. And that, though I'm kind of hoping that somebody else takes care of it for me, because I'm lazy. But one way or another, we should wind up with an unofficial backport, and that whether or not Google supplies an official one at some point in time, we'll find out when they ship. Other stuff that we got in Volta. Battery stats is another one of those ADB shell dump sys categories. How many of you have used ADB shell dump sys to dump data? How many of you think that the output from ADB shell dump sys is intelligible? Yeah, that's pretty much what we get here too. And that ADB shell dump sys battery stats will give you a fire hose of information related to what's going on with the battery, but it's a fire hose of data in stuff that's not very human readable, yet not readily parsed either, and therefore is kind of the worst of both worlds in terms of a data formatting standpoint. Like some of the other ADB shell dump sys categories, there are switches that we can include that will tailor the output. Reset says, don't actually give me output, but clear the roster of data so that from this point onward, we're collecting a fresh set. Useful before you start running some tests. Unplugged says, give me output, but only give me output since the last time we've been unplugged. Versus charged, only give me the output from the time that we were last charged. If you provide your package name, you're going to restrict the output to things that are only related to your package, as opposed to things that may be related to other packages. Now, the problem here is that stuff like Google Play Services, its power-related things that you might be triggering will be from its own package. And so, in some cases, limiting it to your package will be useful. In other cases, you may need to have the full fire hose. Enable full wake history will add a little bit more logging information about the behavior of wake locks, and that either the ones you're raising or if you didn't filter by package, that any app is raising. No auto reset says, hey, when we plug and unplug the device, please go in, do not reset the data, and that the keep may continue logging across the power changes. We can switch back to the demo machine, please. And so, in a moment, I will show you what one of those files looks like. And wink. And so we have 2 tons of information related to what's going on with the battery. How much battery was consumed during the time from the last reset till now. And what are all of the events with an offset from when the reporting began? Were wake locks in? Were wake locks not in? The screen off, running versus not. The problem is that none of this is documented. I mentioned that a lot of what we get, a lot of what's going on with these projects is designed for Google engineers. I am sure that somewhere inside the Googleplex there is a web page that explains what all this notation really means. They haven't published that yet. And so we're kind of taking some educated guesses as to what these particular events all mean. Did I mention it's a fire hose? Yeah, it's a fire hose. Oh, it's a long fire hose. Oh, there we go. And that somewhere in the middle of this, you start getting more interesting information again. And that how long was the screen on during the test time? How long was the device actually running during that period of time? This I happened to run on a Nexus 7 on which I loaded the Android 5.0 image, and so that one was just a Wi-Fi device, and so therefore I didn't have any mobile data. But if on a phone, you're more likely to wind up seeing information about the number of bytes transmitted over the mobile data in addition to stuff that may have been transmitted in that over Wi-Fi, and that Bluetooth, and that the estimated power use, basically the backing data behind the battery blame screen, milliamp hours associated with various UIDs, which in turn are associated with packages. Who was working with late wake locks? And that, like my test app, and that I used 671 wake locks during those 10 hours or so, and that keeping the device awake for a total of about 9 minutes, and so forth. And so there's a lot of information here, a lot of data here, but trying to tease out stuff that's of relevance out of what is a very large text file for just 10 hours worth of data, and that can be somewhat challenging. If we could switch back to the slides, please. Battery Historian is designed to take that input and give us an HTML bit of output. And that designed to be rendered in probably Chrome, though it seems to work okay in Firefox, and that I haven't tried it in IE or anything else. Now, the SDK and that, the release notes and whatnot, they're touting Battery Historian, Battery Historian, Battery Historian, and so you therefore would think that Battery Historian was part of the Android SDK. It's not. It's a Python script that you download from a Google GitHub repository. The QR code leads you to that same URL to be able to download that Python script and a disturbingly short README. The basic recipe for using it is you'll want to enable the full wake history so you get the full wake lock data, probably reset the battery stats, do whatever testing you want, whether that's automated testing and that or manual experimentation with the GUI, up to you. Then you're going to be able to dump the battery stats to a file, whether or not you name it BS for battery stats, and that's up to you. Then you run the Python script in order to be able to generate HTML. And if you're on Windows, I assume you find a Python somewhere. And that in order to generate the output. If we could switch back to the demo machine again. And I turn around and give me a moment to get this loaded up in here and slide over here. And so what this is the same output that I was just showing you in the tabular form, here showing it to you in more of a timeline. And so we see information about the wake locks. And if you hover over one of these things, you will get a little bit more details about, say, for example, who triggered the wake lock, how long did we have the wake lock, and so forth. And that you get a summary of all the different events, and that, control zoom levels, that sort of thing. This does make it somewhat easier to be able to identify what's going on, as opposed to sifting through, many, many kilobytes worth of text data. On the other hand, this is still undocumented in terms of exactly what's going on. We can take some educated guesses, like plugged probably means whether or not the device is plugged in. But for example, the difference between wake lock and wake lock in, not necessarily clear. And so there are kind of limits to what information we can get out of this stuff. But it is available to us, and perhaps we'll be able to get some more documentation eventually. One last switch back to the slides, please. So, now what do we need? We could use a lot more documentation on both battery stats and battery historian so we can make more effective use of the tools they've given us. We could use the JobScheduler compat, whether it's an official one or one that the community creates, and that's so that we can start coding to that API and still support older devices. But we could really use stuff that gives us more knowledge as opposed to raw data. The raw data is useful, but there's a lot of developers whose eyes are going to glaze over at that battery stats output. We need like a power lint sort of deal, and that where it can analyze that output and say, okay, given what we're seeing here, these seem to be some anti-patterns and that are going on. You're using a ton of wake locks. You are causing the radio to wake up lots of times. Things like that can provide high level, here's the things you seem to be doing wrong, here's how to fix them, as opposed to just the sea of data. We need more recipes for being able to run automated tests that don't imply a continuous ADB connection. Because ADB in turn implies USB or Wi-Fi, which in turn has impacts on power consumption. And we specifically want to be able to test these things without having artificial changes in the power in terms of whether or not we're on charging, through a micro USB cable, or whether the Wi-Fi is on for ADB purposes and therefore swamping the behavior that we're trying to measure. And given all this information, we need more kind of indications from libraries and that yes, they've been using these tools in order to try to improve their power performance, and here's how they are in turn exposing things to allow you to tailor them to be able to do a better job of power. So hopefully, given Project Volta, we'll be able to get a lot of these things in the future to be able to do more. JobScheduler in particular right now is something definitely worth considering once we have a backboard. And with that, I will turn it over for questions. As with the other rooms, we've got a pair of microphones, and since I got little chance of hearing you otherwise, if you could step up to a microphone if you have any questions, I'll happy to take them for the next couple of minutes. Don't all race to the microphones, please. Please, no pushing and shoving. Hi.
Hello. You mentioned in your in one of the battery analyses that it has an estimated of battery consumption, and you also mentioned that since we have to do it through ADB, it's normally either connected or through Wi-Fi. If it's connected through the USB, does it give an estimated how much battery is consumed in the reporting?
As far as I know, that reporting is still there. Now, whether or not that reporting is different than what it would be if you were unplugged, I can't say. Because the rest of the device is, of course, used to adapting itself to whether or not we have a continuous source of power. And so it may be keeping CPU cores spun up where otherwise it might be powering them down and things like that. And so you kind of get the Heisenberg uncertainty principle here in that. Just because we tested it with the power on, what's that tell us about when the power isn't on? And that's one of my concerns. And so part of the reason this particular sample that I wrote up was designed to not use something like JUnit or things that implied an ADB connection, and that's just a regular Android app. And you can certainly do that sort of thing, that you can create a regular Android app that is going to go in there and exercise some stuff, and that against the rest of your code. But we could use more simpler tested recipes for that sort of deal.
All right, thank you.
Sure. Any other questions? Your Twitter ID one more time. Oh, I'm sorry, didn't mean that literally. And that my Twitter handle is Commons Guy, COMMONSGUY. Other questions? Okay, if you do have other questions, and that there's another presentation in this room coming up at the top of the hour, I am headed to office hours in the Hackers Lounge up on 3rd, and so happily to take your questions on this topic or anything else related to Android development there. Thank you all for attending, and enjoy the rest of the conference.